In part A, we need to work out 3.67 multiplied by 4.2. Now this is a non-calculator paper, and so it's always easier to work with whole numbers than decimals. And so let's see how we can use whole numbers in order to solve this problem. Now 3.67 is equivalent to 367 divided by 100, and 4.2 is equivalent to 42 divided by 10. And so we can say that 3.67 multiplied by 4.2 is equivalent to 367 multiplied by 42, all divided by 100 and divided by 10. Now if we divide by 100 and then divide by 10 again, that's equivalent to dividing by 1000. And so 3.67 multiplied by 4.2 is equivalent to 367 multiplied by 42, all divided by 1000. Now let's work out 367 multiplied by 42. And we're going to use the lattice method, which is a method of multiplication. And it's okay if you've never come across this method before, because we're going to go through it now. You can see that we've split 367 into 3 digits. We have 3, 6, and 7. And we've done the same with 42. Now we need to multiply the numbers together. In this box, we'd have 3 multiplied by 4, which is equal to 12. And so we'll put 1 in the top triangle and 2 in the bottom triangle. Now this box will contain 6 multiplied by 4, which is equal to 24. And so just like before, we'll have 2 in the first triangle and 4 in the bottom triangle. And let's continue. 7 multiplied by 4 is equal to 28. 3 multiplied by 2 is equal to 6. And since the number 6 is a one-digit number, we'll have 0 in the top triangle and 6 in the bottom triangle. 2 times 6 is equal to 12. And finally, 7 multiplied by 2 is equal to 14. Now we're going to add the numbers inside the boxes, but we're going to do this diagonally. We have to start on the right hand side, and so in this diagonal we have the number 4. Our next set of numbers would be 8 plus 1 plus 2, which is equal to 11. And so just like with column addition, when we have 11 we'll have 1 and carry the 1. And you can see that we've carried the 1 over here. Now the next diagonal would be 2 plus 4 plus 1 plus 6 plus the 1 that we carried from before, which is equal to 14. And so again, we'll write down the number 4 and carry the 1. Now the next diagonal, we have 2 plus 2 plus the 1 that we carried, which is equal to 5. And finally, we have this last diagonal, which is equal to 1. And so we have the numbers 1, 5, 4, 1, 4. And so using the lattice method, we found out that 367 multiplied by 42 is equal to 15,414. But we're interested in finding out 3.67 multiplied by 4.2. And we said that in order to do this, we need to find 367 multiplied by 42 and divide this number by 1000. And so we need to do 15,414 divided by 1000, which is equal to 15.414. And so we've found out that 3.67 multiplied by 4.2 is equal to 15.414. Now in part B, we need to work out 59.84 divided by 1.6. Now we can use the bus stop method in order to work this out. Now we know that 1.6 is equal to 16 divided by 10. And so we can use the bus stop method in order to find 59.84 divided by 16. First we need to find out how many 16s go into 5, and the answer is 0. Then we need to find out how many 16s go into 59, and the answer is 3. We know that 3 16s go into 59 because 3 multiplied by 16 is equal to 48. Well, now we need to find the remainder between 59 and 48. And so we can do 59 take away 48, which is equal to 11, which we've written above the 8. Now the 11 above the 8 turns this number into 118, and we need to find out how many 16s go into 118. We know that 7 16s go into 118, and don't forget the decimal points. 16 multiplied by 7 is 112, and so the difference between 118 and 112 is equal to 6, which we've written above the 4, and so this number now becomes 64. Now we need to find the number of 16s which go into 64. And we know that 4 16s go into 64, because 16 multiplied by 4 is equal to 64. And there's no remainder, and so 59.84 divided by 16 is exactly 3.74. And so let's write this line in a way that looks more like fractions. 3.74 is equivalent to 3.74 divided by 1. And so 59.84 over 16 is equivalent to 3.74 over 1. Now we need to find out 59.84 divided by 1.6. And so we're finding out 59.84 divided by 16 over 10. You can see that on the left-hand side, we've divided the denominator by 10. And so in order to make this equivalent on the right-hand side, we need to multiply the numerator on the right-hand side by 10. And so 59.84 divided by 1.6 is equal to 3.74 multiplied by 10. 3.74 multiplied by 10 is equal to 37.4. And so we've found that 59.84 divided by 1.6 is equal to 37.4. Now this question is worth 6 marks. We get the first mark in part A for saying that 3.67 multiplied by 4.2 is equivalent to 367 multiplied by 42, all divided by 1000. We get the second mark for finding that 367 multiplied by 42 is equal to 15,414. And we get the third mark for correctly finding that 3.67 multiplied by 4.2 is equal to 15.414. We get the fourth mark in part B for a process to find 59.84 divided by 16. We get the fifth mark for finding that 59.84 divided by 16 is equal to 3.74. And we get the sixth and final mark for finding that 59.84 divided by 1.6 is equal to 37.4. Allowing us to get the full 6 marks needed in this question. In this question, we're given a set of numbers and asked to complete the Venn diagram for this information. We're told that the universal set consists of all even numbers less than 19. In set A, we have the numbers 6, 12 and 18, and in set B, we have the numbers 2, 6, 14 and 18. Let's start by finding the numbers that fall within the intersection of A and B. And so these numbers would be numbers that exist in set A and set B. Let's start by comparing set A to set B to find these numbers. The first number in set A is the number 6. We can see that the number 6 exists in set A and set B, and so number 6 falls within the intersection of A and B. We can see that the number 18 is in set A and set B, and so we can say that 18 also falls within the intersection of A and B. Now let's fill in the other numbers. We can see that we have the number 12 left in set A, and so the number 12 is in set A and not in set B, and so it falls within this part of our Venn diagram. And in set B, we have the numbers 2 and 14. 2 and 14 exist in set B, but not in set A. And so we can place 2 and 14 in the Venn diagram outside of circle A, but within circle B. But now we haven't quite finished this diagram, because we're told that the universal set contains all even numbers less than 19, and so some of these numbers do not exist in set A or set B. Let's make a list of all of the even numbers less than 19. We have 2, 4, 6, 8, 10, 12, 14, 16 and 18. We need to find the numbers that don't exist in set A or set B. We know that the number 2 exists in set B, so we can cross this off our list. Now the number 4 does not exist in set A or set B. We can cross 6 off our list because it exists in set A and set B. 8 and 10 do not exist in set A or set B. The number 12 exists in set A, and so we can cross 12 off. 14 exists in set B, and so we can cross 14 off. 16 does not exist in set A or set B. And finally, the number 18 exists in set A and set B, and so we can cross 18 off. And so we're left with the numbers 4, 8, 10 and 16. And so since these numbers are outside of set A and set B, we can place them outside of the two circles. And so we now have a fully complete Venn diagram to represent this information. And we get the full 3 marks in this question for placing each number in the correct place, allowing us to get the full marks needed in this question. In this question, we're asked to work out 4 1/5 take away 2 2/3, giving our answer as a mixed number. Now before we can start, we need to convert these two mixed numbers into improper fractions, because this will allow us to subtract them. So let's start with 4 1/5. 4 1/5 can be written as 4 plus 1/5. We also know that 4 can be written as 20/5, because 20 divided by 5 is equal to 4. And so 4 plus 1/5 is equivalent to 20/5 plus 1/5, which is equal to 21/5. And so 4 1/5 written as an improper fraction would be equal to 21/5. Now we can do the same with 2 2/3. 2 2/3 can be written as 2 plus 2/3. Now to write 2 as a fraction with a denominator of 3, we can say that 2 is equal to 6/3, because 6 divided by 3 is equal to 2. And so 2 plus 2/3 is equivalent to 6/3 plus 2/3, which is equal to 8/3. And so we found that 2 2/3 written as an improper fraction is equal to 8/3. Now when we subtract fractions, we need a common denominator. So we have the two fractions 21/5 and 8/3. We can make both fractions have a denominator of 15 in order for them to have a common denominator. Now to make the fraction 21/5 have a denominator of 15, we need to multiply both the numerator and the denominator by 3. 21 multiplied by 3 is equal to 63, and 5 multiplied by 3 is equal to 15. And so 21/5 is equivalent to 63/15. Now we can do the same thing for 8/3. We want this fraction to have a denominator of 15, and so we can multiply both the numerator and the denominator by 5. 8 multiplied by 5 is equal to 40, and 3 multiplied by 5 is 15. And so 8/3 is equivalent to 40/15. And so to work out 4 1/5 take away 2 2/3, well, we know that 4 1/5 is equivalent to 63/15, and 2 2/3 is equivalent to 40/15. And so we'd need to find 63/15 take away 40/15. Now since they have the same denominator, we just need to focus on subtracting the numerators. 63 take away 40 is equal to 23, and so 63/15 take away 40/15 is equal to 23/15. But now this isn't our final answer, because we need to give our answer as a mixed number. So essentially, to convert from an improper fraction to a mixed number, we'd do the opposite of what we did at the beginning. 23/15 can be written as 15/15 plus 8/15, because 15 plus 8 is equal to 23. Now 15/15 is equivalent to 1. And so 15/15 plus 8/15 can be written as 1 plus 8/15. And as a mixed number, this would be equal to 1 and 8/15. And so we've found that 4 1/5 take away 2 2/3 is equal to 1 and 8/15. Now this question is worth 3 marks. We get the first mark for converting the original mixed numbers into improper fractions. We get the second mark for finding 21/5 take away 8/3 by making these fractions have a common denominator, and for therefore finding that 21/5 take away 8/3 is equal to 23/15. And we get the third and final mark for converting 23/15 into a mixed number, and for therefore correctly finding that 4 1/5 take away 2 2/3 is equal to 1 and 8/15. Allowing us to get the full 3 marks needed in this question. In this question, we're told that at the end of 2017, the value of Tamara's house was £220,000, and the value of Raheem's house at the end of 2017 was £160,000. We're then told that at the end of 2019, the value of Tamara's house had decreased by 20%. And we're also told that the value of Raheem's house had increased by 30%. We need to find out whose house had the greater value at the end of 2019. We can start by deciphering what it means for the value to decrease by 20% and to increase by 30%. The original value of anything will always be equal to 100%. And so if something decreases by 20%, we'd be taking 20% away from the original value. And so a decrease of 20% would be equivalent to 100% take away 20%, which is equal to 80%. And so if something decreases by 20%, we want to find 80% of the original value. And we know that to find 80%, we multiply by 0.8. And so we can therefore say that to find the value of Tamara's house, which had decreased by 20%, we'd have to multiply the original value by 0.8. Well, now let's consider what it means for the value to increase by 30%. We have the original value of 100%, and we have an increase of 30%. And so we'd be finding 100% plus 30%. Now in terms of a multiplier, 100% can be written as 1, and 30% can be written as 0.3. And so we'd be finding 1 plus 0.3, which is equal to 1.3. And so to find an increase of 30%, we'd multiply the original value by 1.3. Now we can find out the value of both of their houses at the end of 2019. We'll start with finding the value of Tamara's house. We know that her house was worth £220,000 at the end of 2017. By 2019, this had decreased by 20%, and so to find the value in 2019, we'd do 220,000 multiplied by 0.8, which is equal to £176,000. Now we can find out how much Raheem's house was worth at the end of 2019. At the end of 2017, Raheem's house was worth £160,000. By 2019, this had increased by 30%, and so would do 160,000 multiplied by 1.3, which is equal to £208,000. We need to find out whose house had the greater value at the end of 2019. We know that Tamara's house was worth £176,000 at the end of 2019, and Raheem's house was worth £208,000 by the end of 2019. And since £208,000 is greater than £176,000, we can say that Raheem's house was worth more at the end of 2019. Now this question was worth 4 marks. We get the first mark for identifying that in order to represent a decrease by 20%, we'd multiply by 0.8, and in order to represent an increase of 30%, we'd multiply by 1.3. We get the second mark for finding out how much Tamara's house was worth at the end of 2019. We get the third mark for finding out how much Raheem's house was worth at the end of 2019. And we get the fourth and final mark for concluding that £208,000 is greater than £176,000, and so Raheem's house was worth more at the end of 2019, allowing us to get the full 4 marks needed in this question. In this question, we're told that Rosie, Matilda and Ibrahim collect stickers. The ratio of the number of stickers Rosie has to the number of stickers that Matilda has to the number of stickers that Ibrahim has is equal to 4 to 7 to 15. We're then told that Ibrahim has 24 more stickers than Matilda. We also know that Ibrahim has more stickers than Rosie, and we need to find out how many more stickers that Ibrahim has compared to Rosie. Now we know that the ratio of the number of stickers Rosie has to the number of stickers that Matilda has to the number of stickers that Ibrahim has is equal to 4 to 7 to 15. Now all ratios can be expressed algebraically, and so this ratio of 4 to 7 to 15 is equivalent to 4x to 7x to 15x, because 4 to 7 to 15 is just the simplified version. Now using algebra, we can say that the number of stickers that Rosie has is equal to 4x, the number of stickers that Matilda has is equal to 7x, and the number of stickers that Ibrahim has is equal to 15x. And so we can say that the number of stickers in total is equal to 4x plus 7x plus 15x, which is equal to 26x. Now we know that Ibrahim has 15x stickers, but we're also told that Ibrahim has 24 more stickers than Matilda. Using algebra, we can see that Matilda has 7x stickers, And so if Ibrahim has 24 more stickers than Matilda, and Matilda has 7x stickers, we can say that Ibrahim has 7x plus 24 stickers in total. And so we know two facts about Ibrahim. We know that he has 15x stickers, and we also know that he has 7x plus 24 stickers. Now 15x and 7x plus 24 refer to the same number, and so we can say that 15x is equal to 7x plus 24. Because both of these expressions represent the same number, we can use our new expression in order to find the value of x. We can take 7x away from both sides, leaving us with 8x is equal to 24. Now to find the value of x, we can divide both sides by 8. 8x divided by 8 is equal to x, and 24 divided by 8, and so we've found that the value of x is equal to 3. Like we said before, the ratio of the number of stickers that Rosie has to the number of stickers that Matilda has to the number of stickers that Ibrahim has is equal to 4x to 7x to 15x. We know that Rosie has 4x stickers, Matilda has 7x stickers, and Ibrahim has 15x stickers. We've also found that x is equal to 3, and so we can find out how many stickers each person has. Rosie would have 4 multiplied by 3 stickers, which is equal to 12. Matilda would have 7 times 3 stickers, which is equal to 21. And Ibrahim would have 15 times 3 stickers, which is equal to 45. Now in this question, we were asked to find out how many more stickers that Ibrahim has compared to Rosie. We can see that Ibrahim has 45 stickers, whereas Rosie has 12 stickers. 45 take away 12 is equal to 33. And so we can say that Ibrahim has 33 more stickers than Rosie does. Now this question is worth 3 marks. We get the first mark for saying that x is equal to 3. We get the second mark for finding the ratio 12 to 21 to 45, which means that Rosie has 12 stickers, Matilda has 21 stickers, and Ibrahim has 45 stickers. And we get the third and final mark for the correct answer that Ibrahim has 33 more stickers than Rosie, allowing us to get the further 3 marks needed in this question. In this question, we're given a diagram which shows a prism. The cross-section of the prism is a right-angled triangle, and the base of the triangle has length 5 centimeters. We're told that the prism has a length of 25 centimeters, and that the prism has a volume of 750 centimeters cubed. We need to work out the height of the prism. Let's start by using our diagram to identify which length is the height. We can see that the height of the prism is this vertical length over here. Now in order to work out the height, we can work out the cross-sectional area of the prism. And we can use our diagram to help us. We know that the prism has a volume of 750 centimeters cubed. To work out the volume of the prism, we'd have to work out the cross-sectional area and then multiply this by the length of 25 centimeters. And in order to work out the cross-sectional area, we need the height of the prism. Now since we know that the volume of the prism is equal to the cross-sectional area is equal to the cross-sectional area multiplied by the length, we can say that the cross-sectional area is equal to the volume divided by the length. The volume divided by the length is equal to 750 divided by 25, which is equal to 30 centimeters squared. And so the cross-sectional area, which is the area of the shaded triangle, is equal to 30 centimeters squared. We can use this area in order to find the height. The cross-sectional area is in the shape of this right-angled triangle, and so we know that the area of this triangle is equal to 30 centimeters squared. We know that the formula for the area of a triangle is equal to the base multiplied by the height, all divided by 2. We can substitute in the values that we know. We know that the area is equal to 30, and the base is equal to 5. And so we can say that 30 is equal to 5 multiplied by the height, all divided by 2. Now in order to go about finding the height, we can start by multiplying both the left-hand side and the right-hand side by 2 in order to get rid of the fraction. 30 multiplied by 2 is equal to 60, and 5 times height, all divided by 2, multiplied by 2 would be equal to 5 times height. And now to find the height on its own, we can divide both the left-hand side and the right-hand side by 5. 60 divided by 5 is equal to 12, and 5 times height divided by 5 is equal to the height. And so we've found that the height of the prism is equal to 12 centimeters. Now this question is worth 3 marks. We get the first mark for saying that the cross-sectional area is equal to 30 centimeters squared. We get the second mark for a complete process to find the height. And we get the third and final mark for the correct answer that the height is equal to 12 centimeters, allowing us to get the full 3 marks needed in this question. In this question, we're given a diagram which shows a cube with edges of length x centimeters and a sphere of radius 3 centimeters. We're told that the surface area of the cube is equal to the surface area of the sphere. We're told that the surface area of the cube is equal to the surface area of the sphere. We're also told that the surface area of a sphere is equal to 4 pi r squared. We need to show that x is equal to the square root of k pi, where k is an integer. Now the first thing that we need to acknowledge is that we're working with a cube. We have a length of x centimeters labelled as the base. Now we know that every length in a cube is equal, and so we can say that the height of the cube is also equal to x centimeters. Well, now that we've established the height of the cube, we can work out the surface area of the sphere. We know that the surface area of the sphere is equal to 4 pi r squared. The sphere has a radius of 3, and so r is equal to 3. 4 pi r squared would be equal to 4 times pi times 3 squared. We know that 3 squared is equal to 9, and so 4 times pi times 9 is equal to 36 pi. And so we've found that the surface area of the sphere is equal to 36 pi. Next we can find the surface area of the cube. And the surface area of the cube would be equal to the total area of all 6 faces in the cube. Since each side of the cube has a length of x centimeters, we know that each face has an area of x squared. And so the total area of all 6 faces would be equal to x squared multiplied by 6, which is equal to 6x squared. We know that the surface area of the cube is equal to the surface area of the sphere. We said that the surface area of the sphere is equal to 36 pi, and the surface area of the cube is equal to 6x squared. We know that 6x squared is equal to 36 pi. Now since we need to show that x is equal to the square root of k pi, we need to find the value of x, and we can start by dividing both sides by 6. 6x squared divided by 6 is equal to x squared, and 36 pi divided by 6 is equal to 6 pi. Now to find the value of x, we can square root both sides. The square root of x squared is equal to x, and the square root of 6 pi is just equal to the square root of 6 pi. And so we've found that x is equal to the square root of 6 pi. We needed to show that x is equal to the square root of k pi, where k is an integer. We said that x is equal to the square root of 6 pi, and so we've found that our integer k is equal to 6. Now this question is worth 4 marks. We get the first mark for finding that the surface area of the sphere is equal to 36 pi. We get the second mark for finding that the surface area of the cube is equal to 6x squared. We get the third mark for saying that 6x squared is equal to 36 pi. And we get the fourth and final mark for using this in order to find that x is equal to the square root of 6 pi, and so k is equal to 6, allowing us to achieve the full 4 marks needed in this question. In this question, we need to solve x squared equals 5x plus 24. You can see that we have an x squared term, and so we're working with a quadratic. Now to solve quadratics, we want to write them in the formula ax squared plus bx plus c is equal to 0. Now to get 0 on the right hand side, we need to move the 5x plus 24 over to the left hand side. And so to move 5x plus 24 over to the left hand side, we have to take away 5x and then take away 24. And so we can say that x squared minus 5x minus 24 is equal to 0. Now to solve this, we need to find the 2 solutions for x. There are different ways that we can do this. We can use the quadratic formula, we can factorise, or we can complete the square. Now with this quadratic, it's probably easiest to factorise. We need to find two numbers which multiply to give minus 24, but add to give minus 5. Well, let's imagine the numbers minus 8 and 3. Minus 8 multiplied by 3 is equal to minus 24, and minus 8 plus 3 is equal to minus 5. And so we've found two numbers which multiply to give you minus 24 and add to give you minus 5. Now since these numbers are minus 8 and 3, we can say that x minus 8, all multiplied by x plus 3, is equal to 0. And so we've now completely factorised our quadratic equation. We can use this factorised form in order to solve for x. Now let's imagine when x minus 8 is equal to 0. If x minus 8 equals 0, we can add 8 to both sides in order to find the value of x. And so we found that x is equal to 8. Now that's just one solution of x, because we also need to find the value of x when x plus 3 is equal to 0. And so taking the 3 over to the other side, we can say that x is equal to minus 3. And so we've now correctly solved our equation in order to find that x is equal to 8 and x is equal to minus 3. Now this question is worth 3 marks. We get the first mark for rearranging and saying that x squared minus 5x minus 24 equals 0. We get the second mark for factorising and for saying that x minus 8 multiplied by x plus 3 is equal to 0. And we get the third mark for using our factorised form in order to find that x is equal to 8 and that x is equal to minus 3. Allowing us to get the full 3 marks needed in this question. In part A, we need to write down the value of 7 to the power of 0. Now we know that any number to the power of 0 is equal to 1. And so 7 to the power of 0 is just equal to 1. In part B, we need to find the value of 3 multiplied by 3 to the power of 6 multiplied by 3 to the power of minus 6. We can use one of our index laws to help us. X to the power of A multiplied by x to the power of B is equal to x to the power of A plus B. And so in order to find 3 multiplied by 3 to the power of 6 multiplied by 3 to the power of minus 6, we need to add their powers together. We can say that 3 is equivalent to 3 to the power of 1. And so 3 multiplied by 3 to the power of 6 multiplied by 3 to the power of minus 6 is equivalent to 3 to the power of 1 multiplied by 3 to the power of 6 multiplied by 3 to the power of minus 6. Now using the index law above, we can say that this is equal to 3 to the power of 1 plus 6 plus minus 6, because we added all their powers together. Now 1 plus 6 is equal to 7, and plus minus 6 is equal to 1, and so this simplifies to 3 to the power of 1. We know that the value of 3 to the power of 1 is equal to 3. And so we found that 3 multiplied by 3 to the power of 6 multiplied by 3 to the power of minus 6 is equal to 3. In part C, we need to find the value of 2 to the power of minus 4. Now with negative powers, that means we need to find the reciprocal, and the reciprocal means 1 over. And so 2 to the power of minus 4 would be equal to 1 over 2 to the power of 4. We know that 2 to the power of 4 is equal to 16, and so 1 over 2 to the power of 4 is equivalent to 1 over 16. And so we've found that the value of 2 to the power of minus 4 is equal to 1 over 16. And finally, in part D, we need to find the value of 27 to the power of 1/3. Now 27 to the power of 1/3 is equivalent to the cube root of 27. The cube root of 27 is equal to 3. And we can check this by finding the value of 3 cubed. 3 cubed is equivalent to 3 to the power of 3, which is equal to 3 multiplied by 3 multiplied by 3. Now this is equal to 27, so the cube root of 27 is equal to 3. And so we found that the value of 27 to the power of 1/3 is equal to 3. Now this question is worth 4 marks, and we get 1 mark for each correct answer. And so we get the first mark for the correct answer in part A, the second mark for the correct answer in part B, the third mark for the correct answer in part C, and the fourth mark for the correct answer in part D, allowing us to get the full 4 marks needed in this question. In this question, we're given a diagram which shows a shape made from 6 identical squares. We're told that the total area of the shape is 5,406 centimeters squared. And in part A, we need to find an estimate for the length of one side of each square, giving our answer correct to the nearest whole number. Well, we can start by finding the area of one square. We know that the total area of the shape is 5,406 centimeters squared. And we know that all 6 squares are identical. And so we can say that the area of one square is equal to 5,406 divided by 6, which is equal to 901 centimeters squared. We can use this area of one square in order to find the length of one side. Now in a square, every side is equal, and so the length and the width are equal. We know that the area of the square is 901 centimeters squared. We can say that the length is equal to x and the width is equal to x. The area of a square is equal to the length multiplied by the width, and so we can say that x multiplied by x is equal to the area, which is equal to 901 centimeters squared. X multiplied by x can be written as x squared, and so x squared is equal to 901. But remember that we need to find an estimate for the length of one side of each square, and so we can round 901 to one significant figure. 901 rounded to one significant figure is 900, and so we can say that x is approximately equal to the square root of 900. We know that the square root of 900 is equal to 30. And so we found that an estimate for the length of one side of each square is equal to 30 centimeters to the nearest whole. Now in part B, we need to find out if our answer to part A is an underestimate or an overestimate, giving a reason for our answer. Now the actual value of x would be equal to the square root of 901. But in order to estimate the length, we rounded 901 to one significant figure, which is equal to 900. And so we can see that we've rounded down from 901, because 900 is less than 901. And so we can say that our answer to part A is an underestimate because we rounded down. And so the actual length of one side of each square would be greater than 30. And so our answer to part B is that part A was an underestimate because the length was rounded down. Now this question is worth 4 marks. We get the first mark for finding that the area of one square is equal to 901 centimeters squared. We get the second mark for finding that x is equal to the square root of 901, which is approximately equal to the square root of 900. We get the third mark for using the fact that x is approximately equal to the square root of 900 in order to find that the estimate for the length of one side of each square is equal to 30 centimeters. And we get the fourth mark for correctly identifying that our answer to part A is an underestimate because the length was rounded down, allowing us to get the full 4 marks needed in this question. In this question, we're given 2 rectangles A and B. All measurements are in centimeters. We're told that the area of rectangle A is equal to the area of rectangle B, and we need to find an expression for y in terms of w. We know that the area of a rectangle is equal to the base multiplied by the height. Rectangle A has a base of 2w plus y and a height of 6, and rectangle B has a base of 3y plus 6 and a height of 7w. Since we know that the area of rectangle A is equal to the area of rectangle B, we can find an expression for both of these areas and equate them together. Let's start by finding the area of rectangle A. The area of rectangle A is the height multiplied by the base, which is equal to 6 multiplied by 2w plus y. And expanding these brackets, we can see that 6 multiplied by 2w plus y is equivalent to 12w plus 6y. Now we can find the area of rectangle B. The area of rectangle B is equal to 7w multiplied by 3y plus 6. Now we can expand these brackets. 7w multiplied by 3y is equivalent to 21wy, and 7w multiplied by 6 is equivalent to 42w. And so the area of rectangle B is equal to 21wy plus 42w. Now since we know that the area of rectangle A is equal to the area of rectangle B, we can say that 12w plus 6y is equal to 21wy plus 42w. And to find the expression for y in terms of w, we need to make y the subject. Now to make y the subject, we want to put the y terms on the left-hand side. And we have two y terms. We have 6y and 21wy. Now we can do this by moving the 21wy to the left-hand side and moving the 12w to the right-hand side. And so by moving the 21wy to the left-hand side and the 12w to the right-hand side, we're left with 6y minus 21wy is equal to 42w minus 12w. All of our y terms are on the left-hand side, but we want to make y the subject. And in order to make y the subject, we want y on its own. Now we can do this by factorising the left-hand side. We can say that 6y minus 21wy is equivalent to y multiplied by 6 minus 21w. And so you can see that we've isolated the y so that we can make y the subject. We can also simplify the right-hand side. 42w and 12w are like terms, and so 42w take away 12w is equal to 30w. Now to find the value of y, we can divide both sides by 6 minus 21w in order to isolate the y on the left-hand side. And so we can say that y is equal to 30w divided by 6 minus 21w, which means that our expression for y in terms of w would be equal to 30w over 6 minus 21w. Now this question is worth 4 marks. We get the first mark for equating the area of rectangle A to the area of rectangle B. We get the second mark for moving the y terms to one side, which we did over here. We get the third mark for factorising the y out of the left-hand side. And we get the fourth and final mark for dividing both sides by 6 minus 21w, and for therefore finding that an expression for y in terms of w is equal to 30w over 6 minus 21w, allowing us to get the full 4 marks needed in this question. In this question, we're given a cumulative frequency table which gives information about the heights in centimetres of 40 plants. And in part A, we need to draw a cumulative frequency graph for this information on the grid below. Now when we draw cumulative frequency graphs, we always plot the cumulative frequency on the y-axis. And now the important thing to remember is that when we plot the heights, we're plotting the upper band. So for example, the first point would be 5 on the x-axis and 4 on the y-axis. We don't use 0 or the midpoint, we use the upper band, 5. And so let's start by plotting our first points, which would be at 5, 4. And so we've plotted the point 5, 4 on our graph. The next point that we'll plot would be 10, 11, which we've plotted over here. Then we need to plot 15, 24, which we've done over here. Then we plot 20, 34, over here. Then 25, 38, which we've plotted here. And finally, we need to plot the point 30, 40, which we've plotted over here. Now to complete the cumulative frequency graph, we need to join these points together. And you can also see that we've extrapolated back to 0. And so we've now correctly drawn a cumulative frequency graph that represents the information given to us in our table. Now in part B, we need to use the graph to find an estimate for the median height of the plants. We know that there are 40 plants in total. And to find an estimate for the median height of the plants, we want to find the height when the cumulative frequency is half of 40, because we're finding the median. Half of 40 is equal to 20. And so we're going to draw a line across from the point at which the cumulative frequency is equal to 20. You can see that we've drawn our purple line up until the cumulative frequency graph. And so we're looking for the value of the height at this point over here. We can draw a vertical line downwards to help us with this. We can see that the height of the plant when the cumulative frequency is equal to 20 lies at this point right here. And reading from our graph, we can see that the height is 13.5 centimeters when the cumulative frequency is equal to 20. And so we've found that an estimate for the median height of the plants is equal to 13.5 centimeters. Now this question is worth 3 marks. We get the first 2 marks for a fully correct cumulative frequency graph, which means that all 6 points need to be correctly plotted, and that the points need to be joined by a smooth line and extrapolated back to 0. And we get the third and final mark in this question for using our graph in order to find an estimate for the median height of the plants, and for finding that the median height of the plants is approximately 13.5 centimeters. Allowing us to get the full 3 marks needed in this question. In this question, we're told that Ted is trying to change 0.43 recurring to a fraction, and we're given the start of his method. Ted says that x is equal to 0.43 recurring, and therefore 10x is equal to 4.34 recurring. He then says that 10x take away x is equal to 4.34 recurring, take away 0.43 recurring. And we need to evaluate Ted's method so far. Well, now mathematically, Ted is correct. If x is equal to 0.43 recurring, it makes sense that 10x is equal to 4.34 recurring, and therefore 10x take away x would be 4.34 recurring, take away 0.43 recurring. But even though he's mathematically correct, his method might not be the best, because we're trying to change 0.43 recurring to a fraction, and so the point of this method would be to get rid of the recurring decimals. Let's take a look at what he did step by step so that we can pinpoint his mistake. If x is equal to 0.43 recurring, that's equivalent to 0.434343 ... And likewise, if 10x is equal to 4.34 recurring, that's equivalent to 4.343434 ... But now to change 0.43 recurring to a fraction, like we said before, we need to get rid of the recurring decimals. Ted does 10x take away x. Now let's think about what this means. If we have 10x take away x, we have 4.343434 ... take away 0.434343 ... We want to take a look at the recurring numbers. If we have something 0.3434 ... take away something 0.4343 ... you can see that we'll be left with some sort of remainder, because the column method would go on forever. What we wanted was for the recurring decimals to be equal, and let's see what we mean by that. If we have something 0.4343 take away something 0.4343, we'll have a perfect remainder of 0. And that's what we want in order to change 0.43 recurring to a fraction. If we have something like this, which is what Ted does, we'd end up with a remainder that we won't be able to solve, and so we won't be able to turn 0.43 recurring into a fraction unless we have 2 numbers whose recurring decimals will leave us with a remainder of 0. And so in order to evaluate Ted's method so far, we can say that Ted has not gotten rid of the recurring decimals. And so we get the 1 mark in this question for identifying this, allowing us to get the full mark needed in this question. In this question, we're given a shape with all of its measurements in centimetres. We're told that the area of the shape is a centimetre squared, and we need to show that a is equal to 2x squared plus 24x plus 46. Now we don't have a direct formula in order to find the area of this shape, but what we can do is to split the shape into 2 rectangles. So by drawing a horizontal line, we have 2 rectangles labelled x and y. Now we know all the measurements that we need to know except the length of this side over here, but we're given the length of this long side and this short side. And so the total length of the long side is x plus 11, and the length of the short side is equal to 4. And so this length is therefore equal to x plus 11 take away 4, because these 2 lengths add up to make the long length. And so we can say that the length of this side is equal to x plus 11 take away 4, which simplifies to x plus 7. Now to find the total area of the shape A, we can find the area of shape X plus the area of shape Y. We know that to find the area of a rectangle, we do the length of the rectangle multiplied by the width. And so the area of rectangle X would be 4 multiplied by x plus 1, which is equal to 4x plus 4. And we can do the same thing in order to find the area of rectangle Y. The length multiplied by the width would be 2x plus 6 multiplied by x plus 7. To find the area of Y, we do 2x plus 6 multiplied by x plus 7. And so we can expand these double brackets. We'll start by finding 2x multiplied by x, which is equal to 2x squared. Next, we want to find 2x multiplied by 7, which is equal to 14x. We then have 6 multiplied by x, which is equal to 6x. And finally, we do 6 multiplied by 7, which is equal to 42. Now we can simplify this further, because 14x plus 6x is equal to 20x. And so we've now found that the area of rectangle X is equal to 4x plus 4, and the area of rectangle Y is equal to 2x squared plus 20x plus 42. We need to show that A is equal to 2x squared plus 24x plus 46, where A is the area of the total shape. And so to find the total area A of the shape, we want to find the area of X plus the area of Y. And so we'd do 4x plus 4 plus 2x squared plus 20x plus 42. Now we've used 3 different colours to simplify this, because the 3 different colours represent the like terms. And so we start off with 2x squared, and so we've looked at all the blue terms. Now to look at the orange terms, we have 4x plus 20x, which is equal to 24x. And finally, looking at the yellow terms, we have 4 plus 42, which is equal to 46. And so we've found that the total area of the shape is equal to 2x squared plus 24x plus 46, which is equal to the area A that we needed to prove. But getting the same answer as the show that does not always mean that we get the full 3 marks in this question, because it depends on whether or not we've correctly shown out our working. And so let's take a look at where we get each of these 3 marks. We get the first mark for finding the area of X and the area of Y. We get the second mark for a process to find the total area of the shape by adding these 2 areas together. And we get the third and final mark for correctly adding these 2 expressions together in order to find that the total area of the shape is equal to 2x squared plus 24x plus 46, which is exactly what we needed to prove. And so we've now achieved the full 3 marks needed in this question. In this question, we need to show that 4x plus 3 over 2x plus 3/5 can be written in the form ax plus b over cx. Now we're being told to add 2 fractions, and when we add or subtract fractions, we need to make sure that the 2 fractions have the same denominator. And so we can make both fractions have a common denominator of 10x. We'll start with the fraction 4x plus 3 over 2x. Now to make this fraction have a denominator of 10x, we need to multiply both the numerator and the denominator by 5, because 2x multiplied by 5 is equal to 10x. Now let's simplify this. 5 multiplied by 4x plus 3 is equal to 20x plus 15, and 5 multiplied by 2x is equal to 10x. And so we've written the fraction 4x plus 3 over 2x in its equivalent form with a denominator of 10x. Now next we want to do the same thing for 3 over 5. Our current denominator is equal to 5, and to get from 5 to 10x, we want to multiply by 2x, and so we can multiply both the numerator and the denominator by 2x. Now 3 multiplied by 2x is equal to 6x, and 5 multiplied by 2x is equal to 10x. And so we've shown that 3 over 5 is equivalent to 6x over 10x. Now that our 2 fractions have the same denominator, we can add them together. And so adding the 2 numerators, we have 20x plus 15 plus 6x, all over a denominator of 10x. And we can simplify this further because 20x and 6x are like terms. 20x plus 6x is equal to 26x, and the 15 will stay how it is. So we can simplify this further by saying that 20x plus 15 plus 6x over 10x is equivalent to 26x plus 15, all divided by 10x. And so we've shown that 4x plus 3 over 2x plus 3 over 5 is equal to 26x plus 15 over 10x. Now this question is worth 3 marks. You get the first mark for saying that 4x plus 3 over 2x is equivalent to 20x plus 15 over 10x, and that 3 over 5 is equivalent to 6x over 10x. We get the second mark for our process to add these fractions together. And we get the third and final mark for correctly adding these two fractions and for getting a final answer that 4x plus 3 over 2x plus 3 over 5 is equal to 26x plus 15 over 10x, allowing us to get the full 3 marks needed in this question. In this question, we're told that there are only 3 red counters and 5 yellow counters in a bag. We're told that Jude takes at random 3 counters from the bag, and we need to work out the probability that he takes exactly 1 red counter. Now we can draw a tree diagram to help us solve this problem. Now we're going to start with the first tree. We have 2 branches, yellow and red, because there are only red counters and yellow counters in the bag. We need to work out the probability that he takes a red counter on his first go, or a yellow counter on his first go. Now there are 3 red counters and 5 yellow counters in the bag, which means that there are a total of 8 counters. Now since there are 5 yellow counters in the bag, the probability that he chooses the yellow counter is equal to 5 out of 8. And applying the same logic, we can say that the probability of choosing a red counter is equal to 3 out of 8. But now these probabilities only apply for the first time that he chooses a counter. We know that Jude takes 3 counters from the bag, and so each time he takes a counter, the number of counters in the bag decreases by 1. Let's say that Jude takes a yellow counter on his first go. We'll have to have new probabilities that he chooses a yellow or red counter on his second go, and so this part of the tree represents the second time that he picks out a counter. Now this is assuming that he takes a yellow counter on the first go. Now if there were 5 yellow counters in the bag to begin with, and he takes 1 yellow counter, that means there are 4 yellow counters left, out of a new total of 7. And so the probability of picking a yellow counter the second time is 4 out of 7. And if he takes a yellow counter the first time, the number of red counters doesn't change, and so the probability of taking a red counter the second time would be equal to 3 out of 7. Now if he takes a yellow counter on the first and second goes, that means we only have 3 yellow counters left. And on the third time he picks, he'll have 6 counters left in total, because there were 8 to begin with, and he's already taken 2. And so the probability of taking a yellow counter the third time would be equal to 3 out of 6. Now the number of red counters still hasn't changed, because he's only taken yellow counters. And so the probability of taking a red counter on the third go would be equal to 3 out of the new total of 6. Now let's imagine that he chooses yellow and then red, and so we need to find out the new probabilities for the third go. Now we found that if he takes a yellow counter the first time, the probability that he takes a red counter the second time would be equal to 3 out of 7. No matter what we pick in the first 2 goes, when it comes to our third go, we'll always have 6 counters left in the bag, and so all of these probabilities for the third go will have a denominator of 6. Now this part of the tree looks at what happens when we take a yellow on the first go and a red on the second go. That means that 1 yellow has been taken from the bag and 1 red has been taken from the bag. So if we started with 5 yellow counters and 1 was taken, we'll have 4 yellow counters left out of a total of 6. And likewise, if we started with 3 red counters and 1 was taken, we'd have 2 red counters out of a total of 6. And so we've completed the first half of our tree diagram, which is what happens when we take a yellow on our first go. Now let's consider what happens when we take red on our first go, and it's the same principles all over again. If we take a red counter on our first go, well now regardless of what colour we've picked, we've already taken 1 counter from the bag, and so our new total for this part of the diagram will have a denominator of 7, because there'll be 7 counters left in the bag on our second go. Now if we take a red the first time, that means the yellows are untouched, and so we still have 5 yellow counters left in the bag out of a total of 7. As for the red counters, if we've already taken 1 and there were 3 to begin with, that means there are 2 left out of a total of 7. Now let's consider what happens when we take a red on the first go and a yellow on the second go. If we've taken a red and then a yellow, that means 2 counters have already been taken from the bag, and so we'll have a total of 6. Now we've taken 1 red and 1 yellow. If 1 yellow was taken and we started with 5 yellow counters, that means the probability of taking a yellow on the third go would be equal to 4 out of 6. And if 1 red has been taken and we've started with 3 red counters, the probability of picking red on the third go would be equal to 2 out of 6. And finally, we're in the last part of our diagram, and we need to consider what happens when he takes red the first time and red the second time. We know that since this is the third go, 2 counters have already been taken, and so there'll be 6 counters left in the bag, and we'll have a denominator of 6. If he's taken red and then red, that means the number of yellow counters in the bag is unchanged, and so we still have 5 yellow counters left, out of a new total of 6. And finally, if we've taken a red counter and then a red counter, that means 2 red counters have already been taken, and we started off with 3, and so there's 1 red counter left. And so if we take red the first time and red the second time, the probability of taking red the third time would be equal to 1 out of 6. And so we now have a fully complete tree diagram, which represents the first time he takes a counter, the second time he takes a counter, and the third time he takes a counter. And we can use this diagram in order to help us work out the probability that he takes exactly 1 red counter. Let's consider what it means for Jude to have taken exactly 1 red counter. If he takes exactly 1 red counter, that means he can only have picked red 1 time. And so the different combinations for that would be picking red first and then yellow, or picking yellow first and then yellow, or picking yellow first and then red. We'll start with the probability of taking red, then yellow, and so we can follow the probabilities on our diagram. Red, then yellow would be 3 over 8 multiplied by 5 over 7 multiplied by 4 over 6. Now if we have an or, that means we add the probabilities together. And so we'll add this probability to the probability of taking yellow, red, and then add the probability of taking yellow, red. Now let's find the probability of yellow, red, yellow. Now following our tree diagram, we start with yellow, then red, and then yellow again. And so we'll have 5 over 8 multiplied by 3 over 7 multiplied by 4 over 6. And finally, we have the probability of taking yellow, red. And so to follow yellow, red on our diagram, we'll do 5 over 8 multiplied by 4 over 7 multiplied by 3 over 6. Well, now let's simplify. 3 over 8 multiplied by 5 over 7 multiplied by 4 over 6 is equal to 60 out of 336. 5 eighths multiplied by 3 sevenths multiplied by 4 over 6 is also equal to 60 over 336. And 5 over 8 times 4 over 7 times 3 over 6 is also equal to 60 over 336. And so adding these 3 fractions together, well, they have the same denominator, so we only need to worry about adding the numerators. 60 plus 60 plus 60 is equal to 180. And so 60 over 336 plus 60 over 336 plus 60 over 336 would be equal to 180 over 336. And so we've now found that the probability that he takes exactly 1 red counter is equal to 180 over 336. Now this question is worth 4 marks. We get the first mark for our diagram with all of the correct probabilities. We get the second mark for finding the probability of red, yellow, the probability of yellow, red, and the probability of yellow, red. We get the third mark for a process to add these 3 probabilities together. And we get the fourth and final mark for the correct answer that the probability that he takes exactly 1 red counter is equal to 180 over 336, allowing us to get the full 4 marks needed in this question. In this question, we need to show on the grid, by shading, the region that satisfies all of these inequalities. We have 2y plus 4 is less than x is less than 3, and y is less than 6 minus 3x. And we need to label the shaded region the letter R. Now in order to shade these regions, we need to draw these 3 lines. And so we have the line 2y plus 4 is less than x. Now we want to have this line in the form y equals mx plus c, so that we're able to plot it. We can start by moving the 4 to the other side, and so we'll have 2y is equal to x minus 4. Now to make y the subject, we want to divide both sides by 2, which will leave us with y is less than half x minus 2, and you can see that this is in the form y equals mx plus c, where the gradient m is equal to a half, and the y-intercept c is equal to minus 2. Now the line x is less than 3 is already something that we can plot, so we can leave that how it is. And then we have y is less than 6 minus 3x. Now y is already the subject of this expression, but we can write it in the form y equals mx plus c by making the minus 3x come first. And so we can write this as y is less than minus 3x plus 6. We need to draw each of the 3 lines in the purple boxes. We'll start with y is less than half x minus 2. We know that the y-intercept is equal to minus 2, and so we can label this point on our graph. We have the y-intercept of minus 2, and now we need to use our gradient in order to draw the line. We know that the gradient is equal to the change in y divided by the change in x. We have a gradient of 1 over 2, and so the change in y would be equal to 1, and the change in x would be equal to 2. If our change in y is equal to 1, we go 1 space upwards, and if our change in x is equal to 2, we go 2 spaces to the right. And so our new point would be at the coordinate 2 minus 1. And so we can apply the same principle for the rest of this line. Now you can see that we've used our gradient of 1 over 2 in order to plot the rest of the points of this line. And now we can draw the line by joining these points together. But now remember that we're dealing with inequalities. We said that y is less than half x minus 2. And so the region where y is less than half x minus 2 would be anything below this line. And so we can draw arrows that point in the direction of this region. Now our next line is x is less than 3. Now to draw the line of x is equal to 3, we'd be drawing a vertical line at the point where x is equal to 3. Now we need to find the region for which x is less than 3. And so x is less than 3 when x is equal to 2, 1, 0, minus 1, minus 2, and so on. And so you can see that the region where x is less than 3 would be the region to the left of the line. And again, we can draw arrows in order to show this. Now the last line that we need to draw is the line y is less than minus 3x plus 6. We have a y-intercept of 6, and so we can mark the point on our graph where the y-coordinate is equal to 6. And so we've drawn this point over here. Now we can use our gradient in order to draw the rest of our line. This line has a gradient of minus 3. Minus 3 is equivalent to minus 3 over 1. And so if the gradient is equal to the change in y divided by the change in x, we can say that the change in y is equal to minus 3, and the change in x is equal to 1. If we have a change in y of minus 3, we're going to go 3 spaces downwards. And if we have a change in x of 1, we're going to go 1 space to the right. And so we can mark this point on our graph. And now that we've marked this point over here, we can apply the same principle in order to draw the rest of the points on this line. Now we can join these points together to draw our line. Now that we've drawn the line y equals minus 3x plus 6, we need to look at the inequality. It says that y is less than minus 3x plus 6, and so we need to look at the area below the line. And so again, let's draw some arrows. Now on our graph, each of the 3 lines are drawn with their associated arrows, and so we need to find the region that satisfies all of these inequalities. And so this area would be one where you can see all 3 arrows. And so we can see that over here. You can see that we have the arrows from the line y is less than half x minus 2. We then have the arrows from the line x is less than 3. And then we have the arrows from the line y is less than minus 3x plus 6. And so we can see that this region over here is our shaded region. And so you can now see that we've firstly made our diagram a lot neater, and of course we've shaded the region which satisfies all of the inequalities above. Now this question is worth 3 marks. We get the first 2 marks for correctly drawing each of the 3 lines. And we get the third and final mark for the correctly shaded area, which you can see in our diagram is shaded in purple, allowing us to get the full 3 marks needed in this question. In this question, we're given a trapezium ABCD. We're told that the area of the trapezium is equal to 66 centimeters squared. And we're also told that the ratio of the length of AB to the length of CD is equal to 2 to 3. We need to find the length of AB. Now let's start by using the fact that the ratio of the length of AB to the length of CD is equal to 2 to 3. This means that AB has 2 parts and CD has 3 parts. And so that would mean that there are 5 parts in total. And like we said, AB has 2 of these 5 parts and CD has 3 of these 5 parts. And so already you can see that we're starting to form a fraction. We can say that the length of AB is 2 out of 5x, and that the length of CD is 3 out of 5x, where x is equal to the value of 1 part. And so we can label this on our diagram. We labelled the length AB as 2 out of 5x, and the length CD as 3 out of 5x. Now another thing that we can label on our diagram is the height of the trapezium. The height is the vertical length of the trapezium, which we've labelled in blue. Now let's see if we can work out this height. You can see on our diagram that we have a right angled triangle over here, and so we can use this in order to find the height. We've drawn a version of this triangle down below. We have the length BC, we have a 30-degree angle, and we have the height. We know that the length BC is equal to 6 centimeters, and so relative to the 30-degree angle, we can say that the height is the opposite side, and the length BC is the hypotenuse. And so given that we have a right angle triangle, and we need to find the length, we're going to be using our trigonometric ratios, either sine, cos, or tan. Now we have the opposite side and the hypotenuse, which means that we need to use sine, because sine is equal to the opposite over hypotenuse. And so we can say that sine 30 is equal to the opposite over the hypotenuse, which is equal to h over 6. Now this is a non-calculator paper, and so we're not going to be able to use our calculator in order to find the value of sine 30. But luckily, sine 30 is one of the trigonometric values that we should know by heart, and so sine 30 is equal to 1 over 2. Since we said that sine 30 is equal to h over 6, we can say that 1 over 2 is equal to h over 6, because sine 30 is equal to 1/2. And so to find the value of h, we can multiply both sides by 6. 1 over 2 multiplied by 6 is equal to 3, and h over 6 multiplied by 6 is equal to h. And so we've now found that the height of the trapezium is equal to 3 centimeters. Now that we've found the height of our trapezium, we can use this in order to find the length of AB. Now we were given the area of the trapezium, which is equal to 66 centimeters squared. Now let's see if we can use the formula for the area of the trapezium in order to find an expression for the length AB. We know that the area of the trapezium is equal to A plus B over 2, all multiplied by the height. And A plus B are the 2 horizontal sides of the trapezium. And so looking at the formula for the area of the trapezium, we'll let A equal 2 out of 5x and B equal 3 out of 5x. And so we can say that the area, which is equal to 66, is equal to 2 out of 5x plus 3 out of 5x, all divided by 2, and then all multiplied by the height of 3. And so we can use this in order to find the length AB. We need to simplify this expression first. 2 out of 5x plus 3 out of 5x is equal to x. And so the area of 66 is equal to x over 2, all multiplied by 3. Now to get rid of this 3 here, we can divide both sides by 3. 66 divided by 3 is equal to 22, and dividing the right hand side by 3 will leave us with x over 2. And finally, we can use this in order to find the value of x by multiplying both the left hand side and the right hand side by 2. 22 multiplied by 2 is 44, and x over 2 multiplied by 2 is equal to x, and so we've found that the value of x is equal to 44. Now remember that we need to find the length of AB, and we can use our value of x in order to help us to do this. We said that the length of AB is equal to 2 out of 5x. Now that we know the value of x, we can substitute this in order to find the actual length of AB. And so if x is equal to 44, AB is equal to 2 out of 5 multiplied by 44, which is equal to 17.6 centimetres. And so we've now found that the length of AB is equal to 17.6 centimetres. Now this question is worth 5 marks. We get the first mark for saying that sine 30 is equal to h over 6. And we get the second mark for using this in order to find the value of h, and we said that h is equal to 3. We get the third mark for using the formula for the area of the trapezium to find the expression that 66 is equal to 2 out of 5x plus 3 out of 5x divided by 2, all multiplied by 3. We get the fourth mark for correctly finding the value of x. And we get the fifth and final mark for using the fact that x is equal to 44 and that AB is equal to 2 out of 5x in order to correctly find that the length of AB is equal to 17.6 centimetres, allowing us to get the full 5 marks needed in this question. In this question, we need to show that the fraction 8 plus root 12 divided by 5 plus root 3 can be written in the form a plus root 3 over b, where a and b are integers. Now when we have a fraction with a third in the denominator, we need to rationalise the denominator, and in this case we can do so by using difference of two squares. Since we have a denominator of 5 plus root 3, in order to get rid of the third in the denominator, we want to multiply both the numerator and the denominator by 5 minus root 3. And so by doing this, the third in the denominator will cancel out. Now if we multiply both the numerator and the denominator by 5 minus root 3, we'll end up with this fraction. We have 8 plus root 12 multiplied by 5 minus root 3 in the numerator, and 5 plus root 3 multiplied by 5 minus root 3 in the denominator. And so we can expand these double brackets. Let's start with the numerator. We have 8 multiplied by 5, which is equal to 40. Then we have 8 multiplied by minus root 3, which is equal to minus 8 root 3. We then have root 12 multiplied by 5, which is equal to 5 root 12. And then root 12 multiplied by minus root 3, which is equal to minus root 3 multiplied by root 12, which we can simplify in the next step. Now for the denominator. We'll start with 5 multiplied by 5, which is equal to 25. Then we have 5 multiplied by minus root 3, which is equal to minus 5 root 3. Then we have root 3 multiplied by 5, which is equal to plus 5 root 3. And finally, we have root 3 multiplied by minus root 3, which is equal to minus root 3 multiplied by root 3, which we'll simplify in the next step. Now let's take a closer look at root 12. 12 is equivalent to 4 multiplied by root 3, and so we can say that the square root of 12 is equivalent to the square root of 4 multiplied by 3. Now using our third laws, we can say that the square root of 4 multiplied by 3 is equivalent to the square root of 4 multiplied by the square root of 3. We can simplify the square root of 4 because we know that root 4 is equal to 2. And so we can see that root 12 can be written as 2 root 3. And so the term in our numerator is 5 root 12, which we can now rewrite. 5 root 12 is now the same as 5 multiplied by 2 root 3. Now 5 times 2 is equal to 10, and so 5 multiplied by 2 root 3 is equal to 10 root 3. Now another third law that will help us is the fact that root a multiplied by root a is equal to a. And so this will be useful in the denominator, where we have root 3 multiplied by root 3, which we now know would be equal to 3. And finally, where we have root 3 multiplied by root 12, that's equivalent to the square root of 3 times 12, and so root 3 times root 12 is equivalent to root 36. And so using all of this information, let's simplify this fraction. Now looking at our numerator, 40 will stay the same, minus 8 root 3 will stay the same, but we'll say that 5 root 12 is equal to 10 root 3, and root 3 multiplied by root 12 is equal to root 36. And so we end up with 40 minus 8 root 3, plus 10 root 3 minus root 36 in the numerator. And now let's simplify the denominator. You can see that the minus 5 root 3 plus 5 root 3 will cancel out to 0, and so we'll be left with 25 take away root 3 times root 3, which is equivalent to 25 take away 3. Now let's continue to simplify this in the next step. Looking at the numerator, we can see that minus 8 root 3 plus 10 root 3 is equivalent to 2 root 3, and then root 36 is equal to 6. And so the numerator will become 40 plus 2 root 3 minus 6. And we can also simplify the denominator because 25 take away 3 is equal to 22. Now we can simplify this again. In the numerator we have 40 plus 2 root 3 take away 6. 40 take away 6 is equal to 34, and so this fraction becomes 34 plus 2 root 3 all divided by 22. But this isn't our final answer, because we need to write this in the form a plus root 3 over b. The fraction that we have is 34 plus 2 root 3 over 22, and so we need to get rid of this 2. In order to do this, we can divide both the numerator and the denominator by 2, which will leave us with the fraction 17 plus root 3 over 11. And so we've found that the fraction 8 plus root 12 over 5 plus root 3 can be written in the form a plus root 3 over b, where a is equal to 17 and b is equal to 11. Now this question is worth 4 marks. We get the first mark for a process to rationalise the denominator by multiplying both the numerator and the denominator by 5 minus root 3. We get the second mark for saying that root 12 is equivalent to 10 root 3. We get the third mark for continuing to simplify until we get to 34 plus 2 root 3 over 22. And we get the fourth and final mark for dividing both the numerator and the denominator by 2 in order to make sure that we've written our answer in the form a plus root 3 over b, which means that we'll end up with a final answer of 17 plus root 3 over 11, allowing us to get the full 4 marks needed in this question. In this question, we're given a diagram which shows a graph of x squared plus y squared equals 30.25. We need to use our graph to find estimates for the solutions of the simultaneous equations x squared plus y squared equals 30.25 and y minus 2x is equal to 1. Now let's consider what this question is asking us. Now when we're asked to find the estimates for the solutions of the simultaneous equations, we're being asked to find the points at which the circle and the line intersect. And so in order to find the points at which the circle and the line intersect, we need to draw the line on our graph. Now, as you can see, the line has the equation y minus 2x equals 1. But we're used to graphs in the format y equals mx plus c, and so let's rearrange the equation that we've been given. To make this equation in the format y equals mx plus c, we want to move the minus 2x over to the other side. And so moving the minus 2x, we'll end up with y equals 2x plus 1. Now we can see that this is in the format y equals mx plus c, where m is equal to 2 and c is equal to 1. Now m is the gradient. We know that the gradient is equal to the change in y divided by the change in x. And we also know that the gradient of our line is equal to 2. And so to write this in the form change in y over change in x, we can say that 2 is equal to 2 divided by 1. We have the change in y in the numerator and the change in x in the denominator. And so using the fact that our gradient is equal to 2 over 1, we can say that the change in y is equal to the numerator of 2, and the change in x is equal to the denominator of 1. And so these small triangles that we see over here is the Greek letter delta. And so in maths, delta generally means the change in. And so when we have delta y is equal to 2, it means the change in y is equal to 2. And when we have delta x equals 1, we're saying that the change in x is equal to 1. Well, now that we really understand what our gradient means, and we have a y-intercept of 1, we can begin to plot this line. Now we'll start by plotting our y-intercept of 1. Now we said that our gradient is equal to 2, which means that the change in y is equal to 2, and the change in x is equal to 1. And so our change in y of 2 means that our y-coordinates will go up by 2, and our change in x of 1 means that our x-coordinates will go to the right by 1. and so going 2 up and 1 to the right, our new coordinates will be at the points 1, 3. Now we can continue to apply this logic by doing the same thing again. And so our next points will be at 2, 5, and so on. And so we've now plotted each point on the line, which you can see has a gradient of 2 and a y-intercept of 1. Let's join these points together. Well, now that we've drawn our line on the graph, to find the estimates for the solutions of the simultaneous equations, we need to find the coordinates at which the circle and the line intersect. You can see that they intersect up here, and again down here. And to find the coordinates of these 2 points, we can draw lines to the coordinate axes in order to make it easier to see. And now these blue lines will help us to find the coordinates of the 2 points of intersection. Now looking at the point of intersection at the top, you can see that the x-coordinate of the point of intersection would be equal to 2.1, and the y-coordinates of the point of intersection would be equal to 5.1. So our first solution of the simultaneous equations would be 2.1, 5.1. But now we need to find the coordinates of the point of intersection at the bottom. You can see that this point of intersection has an x-coordinate of minus 2.9, and it has a y-coordinate of minus 4.7. And so our final solution to these simultaneous equations would be minus 2.9 minus 4.7. And so you can see that we've used our graph in order to find estimates for the solution of the simultaneous equations, and we've found that the two solutions are equal to 2.1, 5.1, and minus 2.9 minus 4.7. Now this question is worth 3 marks. We get the first mark for correctly plotting the line y equals 2x plus 1. We get the second mark for finding the solution of the first point of intersection, which has the coordinates 2.1, 5.1. And we get the third mark for finding the second and final solution, which has coordinates minus 2.9, minus 4.7. Allowing us to get the full 3 marks needed in this question. In this question, we're given 2 functions f and g. We're told that f of x is equal to 3x squared plus 1 for all values of x greater than 0, and we're told that g of x is equal to 4 over x squared, and again for all values of x greater than 0. In part A, we need to work out gf1. Now let's consider what this means. gf1 is the same as g of f of 1. We can write this in a slightly different way. gf1 can be written as g of f of 1, like we said. And so we can start by finding f of 1. Now we know that f of x is equal to 3x squared plus 1. And so to find f1, we're going to replace x with 1. If f of x is equal to 3x squared plus 1, f of 1 is equal to 3 multiplied by 1 squared plus 1. Now 3 multiplied by 1 squared is equal to 3, and then add 1 is equal to 4. And so we found that f of 1 is equal to 4. But now we were asked to find g of f of 1. Since we already know that f of 1 is equal to 4, we're just finding g, 4. And so we'll apply the same principle again. Now we know that g of x is equal to 4 over x squared. Since we're finding g, 4, we're going to replace every x with a 4. And so if g of x is equal to 4 over x squared, g of 4 would be equal to 4 over 4 squared. 4 squared is equal to 16, so this is equal to 4 out of 16. And simplifying this fraction, we can say that g of 4 is equal to 1 out of 4. And so we've successfully found that gf1 is equal to 1 out of 4. Now in part B, we're told that the function h is such that h is equal to fg to the minus 1. And so we need to find the function hx. Now the first thing that we can identify is that fg to the minus 1 is the inverse function of f of g. And so in order to solve this problem, we can start by finding f of g, and then we can find the inverse in order to find the function h. Now we know that f of x is equal to 3x squared plus 1. And so to find f of g, well, if g is equal to 4 out of x squared, we're finding f of 4 out of x squared. And so using this function, we need to replace every single x with a 4 out of x squared. And so f of 4 out of x squared is equal to 3 multiplied by 4 out of x squared all squared plus 1. And so you can see that where there was an x, we replaced it with 4 out of x squared. Now let's begin to simplify. 4 out of x squared all squared would be equal to 16 out of x to the power of 4. And so f of 4 out of x squared would be equal to 3 multiplied by 16 over x to the power of 4 plus 1. 3 multiplied by 16 is equal to 48. And so 3 multiplied by 16 over x to the power of 4 is equal to 48 out of x to the power of 4. And so we can say that f of g is equal to 48 over x to the power of 4 plus 1. And so we've now found the value of f of g. We need to find fg to the minus 1, which is the inverse of f of g. And so we need to find the inverse function of 48 over x to the power of 4 plus 1. And now in order to find the inverse, we're going to let y equal 48 over x to the power of 4 plus 1. And so this method is always the best way to find the inverse of a function. We replace the function with y, and then we need to make x a subject. So we said that y is equal to 48 over x to the power of 4 plus 1, and now we need to make x a subject. We can start by moving the 1 over to the left hand side, and we'll say that y minus 1 is equal to 48 over x to the power of 4. We can now multiply both sides by x to the power of 4, and say that x to the power of 4 multiplied by y minus 1 is equal to 48. Now to make x to the power of 4 the subject, we can divide both the left hand side and the right hand side by y minus 1. And so x to the power of 4 is equal to 48 divided by y minus 1. And now finally, to make x a subject, we can take the fourth root of both sides. The fourth root of x to the power of 4 is just equal to x. And the fourth root of 48 over y minus 1 is just equal to the fourth root of 48 over y minus 1. And so we've found that x is equal to the fourth root of 48 over y minus 1. But now remember that we're finding the inverse function of f of g. Now that we've made x a subject, we can swap the y with an x, and we can swap the x with the inverse function. And the inverse function is equal to fg to the minus 1. And so we can say that fg to the minus 1 is equal to the fourth root of 48 over x minus 1. And so we've now found that the function h of x is equal to the fourth root of 48 over x minus 1. Now this question is worth 6 marks. We get the first mark in part A for saying that f of 1 is equal to 4. And we get the second mark in part A for finding g of 4, and for therefore finding that gf1 is equal to 1 out of 4. We get the third mark in part B for finding f of g, which we said is equal to 48 over x to the power of 4 plus 1. We get the fourth mark for a process to find the inverse of f of g, and for setting up the equation y equals 48 over x to the power of 4 plus 1. We get the fifth mark for rearranging in order to find that x to the power of 4 is equal to 48 over y minus 1. And we get the sixth and final mark for using all of this in order to find that the inverse function of f of g is equal to the fourth root of 48 over x minus 1, allowing us to get the full 6 marks needed in this question. In this question, we need to find the coordinates of the turning point on the curve with the equation y equals 9 plus 18x minus 3x squared. Now we have the graph of y equals 9 plus 18x minus 3x squared. We can write this in the form ax squared plus bx plus c. And so changing the order around, y is equal to 9 plus 18x minus 3x squared is equivalent to y equals minus 3x squared plus 18x plus 9. Now to find the coordinates of the turning point on the curve, we need to complete the square. And so to start to complete the square, we need to factorise out the minus 3. And so we can say that y is equal to minus 3 multiplied by x squared minus 6x, and we can leave the plus 9 alone. Now we're going to have to use this rule in order to complete the square. We know that x squared minus 2ax is equal to x minus a all squared minus a squared, which sounds more confusing than it really is. Let's say that x squared minus 2ax is equivalent to x squared minus 6x, and so we can immediately see that the 2a is equal to 6. We said that this is equal to x minus a all squared minus a squared. So if 2a is equal to 6, we can say that a is equal to 3. And so if a is equal to 3, x minus a all squared minus a squared would be equal to x minus 3 all squared, take away 3 squared. We know that 3 squared is equal to 9, and so this will become x minus 3 all squared minus 9. And so we can see that x squared minus 6x becomes x minus 3 all squared, take away 9. Now the next step would be to multiply by minus 3. And so to expand this, we'll do minus 3 multiplied by x minus 3 all squared, and then we'll do minus 3 multiplied by minus 9. Minus 3 multiplied by x minus 3 all squared can just be written as minus 3 multiplied by x minus 3 all squared. And now minus 3 multiplied by minus 9 would be equal to positive 27. And then we have the plus 9 at the end. We can simplify this further because 27 plus 9 is equal to 36. And so y is equal to minus 3 multiplied by x minus 3 all squared plus 36. Now we're in the perfect position in order to find the turning point of the curve. And so we can use this rule to help us. If y is equal to x minus a all squared plus b, the turning point has the coordinates a, b. And so in our situation, we can ignore the minus 3 in front of the brackets. Now in our equation, a is equal to 3, and b is equal to 36. And so we can say that the turning point of our curve has the coordinates AB, which is equal to 3, 36. And so we've found that the coordinates of the turning point of the curve with the equation y equals 9 plus 18x minus 3x squared is equal to 3, 36. Now this question is worth 4 marks. We get the first mark for factorising the minus 3 out of our equation. We get the second mark for our process to complete the square, and for saying that x squared minus 6x is equivalent to x minus 3 all squared minus 9. We get the third mark for fully completing the square, and for therefore saying that y is equal to minus 3 multiplied by x minus 3 all squared plus 36. And we get the fourth and final mark for using this in order to find that the turning point of our curve has the coordinates 3, 36. Allowing us to get the full 4 marks needed in this question.